Okay, so we've seen our saturated envelope. We've got our bubble point and our dew point. Critical point is at the top of the saturated envelope. This is where the critical temperature and the critical pressure lines meet. Okay, that's probably for another masterclass as well. But anything on the left-hand side of the saturated envelope is liquid, and the further we go left, the more subcooling we have. Alternatively, on the right of the saturated envelope, we have vapor, and the further to the right we go, the more superheating that we have on that vapor. You have the next slide, please. Okay, so definitions of subcooling and superheat. Subcooling, right, is any heat removed from a liquid below its condensing point, and superheat is any heat added to a vapor above its boiling point. Can I have the next slide, please? Well, that can be a little bit confusing. So what I've done is simplified those definitions because we've talked a lot about equilibrium, saturation, and what that is. So the definitions that I've come up with here is subcooling is heat removed from the liquid below the saturation temperature stroke pressure, because the temperature and pressure are related to each other. Okay, and superheating is any heat added to the vapor above the saturation pressure or temperature. Okay, so those definitions just put into relation the saturation, superheating, and subcooling. Okay, can I have the next slide, please? So what this means is if we take the liquid from our gas bottle and we run it along a liquid line and we cool it down further, we have subcooled liquid. And also if we take vapor from the top of the gas bottle and we run it across along a suction line, and then we heat that vapor up further, we have superheated vapor. So hopefully that's fairly easy to understand what subcooled liquid and superheated vapor is. Okay, can we have the next slide, please? And most of you will be familiar with this, and this shows where on the pressure enthalpy diagram these different states of refrigerant are. So we have saturation in the middle, two different pressures, two different temperatures, and that's in the condenser and the evaporator, which if we've got a good system, that's the only places that saturated liquid and vapor should be. Okay, on the right-hand side of the envelope, we've got the suction superheat, then the compression. At the top, we have delivery superheat, back through saturation, and then out the other side. Hopefully, if we've got a healthy system, we've got a little bit of subcooling, a little bit of natural subcooling that I'll come on to through the expansion valve, and it drops back into the saturated envelope.